Welcome back to our EV channel. So today we are going to practically measure an unknown inductance using an ACE bridge. So this is the practical setup of how to measure the unknown capacitance using ACE bridge. So here you have an bridge network. So in this bridge network, let us try to see what is the importance of this bridge network. So coming to the bridge network, this is the circuit diagram of bridge network. Actually, we are giving the excitation at P. So let's try to mark the nodes. So this is A, B, C, D. So we are giving excitation at C and D, and we are connecting the galvanometer at A and B. So this is the concept here is what you have to do is, so we have 4 terminals. At 2 terminals we have to give the supply, and remaining 2 terminals we have to connect the galvanometer. So try to do the balancing of the bridge in such a way that the voltage across B and C should be C. What I want to say is the voltage across VAB is equal to VA minus VB. We try to adjust the decade inductance box as well as resistors such a way that the voltage across A is 5 volts and the voltage across B is also 5 volts. So 5 minus 5 will become 0 volts. So whenever the voltage is same here, therefore current I is equal to V by R. So current I equal to V by R, 0 by R, therefore the current in the deflector will be 0, therefore it doesn't shows any deflection, the ammeter. So in order to validate it, so now we want to balance the voltage at A point and the voltage at B point using this ACE bridge. So this is the concept of ACE bridge. Now coming to the circuit diagram. So this is the circuit diagram of the ACE bridge. So now you see here how to give the supply is. So this is very simple. So here we have the detector. So in the olden days we used to use an headphones to identify the signal. Now we are upgraded. We are using an oscilloscope to measure the signal which is detected from the galvanometer. So this detector we are connecting to the detector point, and this is the unknown inductance. Okay, so unknown inductance means, so here we have to inject. So this is the one terminal of the inductor, connect to the unknown terminal of the inductor. The another terminal of the inductor you connect to this inductance. So here we can measure 3 unknown inductance, 1, 2, 3. So now I'm keeping in the third position to measure this unknown inductance. Now we want to give the supply. So these are the supply terminals, this is the AC supply. So now connect one end of the AC supply to the supply terminal. So using one patch cord, and by using another patch cord connect the negative terminal to the negative. So very simple connections, this no need to feel complexity. The AC supply is given to the board, and 2 terminals are connected to the CRO, cathode ray oscilloscope, and another 2 terminal you can see here. So the unknown capacitance we are going to measure. Actually the problem here is this unknown capacitance is not known. This we are measuring using an ACE bridge. Oh, sorry, this unknown inductance you are going to measure using an ACE bridge. So we will try to do by this kit, and we'll try to verify it with an known value. So the known value of decade capacitance box is 3 microhenry. This by using this known we'll find the unknown such a way that we can cross check the answer we are getting is correct or wrong. So now see here, the procedure here is already I told. So we have to give the supply and just give the supply. As soon as you turn on the supply, here you can see here a noise is generated. So in order to generate, first we have to give the noise, and then we want to make this voltage magnitude as 0. So that's why we have to keep the capacitance will be in 0. So we have to keep a minimum capacitance of 0.01 microfarad and introduce the disturbance using the cube. So this is nothing but the resistance. We are introducing a resistance of around, it will be in 0. We want to introduce approximately 1000 ohm and just vary only the R value. Now I will be slowly varying the R value. You can see that this magnitude will reduce its magnitude. Now let us try to perform. So now the R value is 0. Now I am keeping it as a 1 kilo ohm. You can see here the magnitude of the signal magnitude slowly decreases. You can see the magnitude of the signal is slowly decreasing. So which says that the bridge is getting balanced. You can see the magnitude is trying to become as 0. So now you can see here almost all the signal is balanced, and you are getting an straight line. So still the disturbance is there. I am going to adjust this. So now we can see here. So now I introduced around 10 kilo ohm plus 100 kilo ohm plus 300 kilo ohm. Okay, this is the R value I set it, and the capacitance value I had default I given is 0.01 microfarad.